Let's master chemical kinetics. In just a few minutes, we're going to tear through one of the most scoring chapters for your JEE exam. And hey, make sure you stay till the end, because I'm dropping all the key formulas, graphs, and the tricks that'll help you win on exam day. All right, let's dive right in. Before we touch any formulas, we got to get our heads around the one big question that chemical kinetics is all about. So remember, thermodynamics tells you if a reaction is even possible. But kinetics is all about how fast it gets there. It's all about the speed, plain and simple. So what is it? Put simply, it's just how fast your reactants are disappearing or how quickly your products are showing up. You can think of it as the speedometer for your chemical reaction. Now, this slide shows a really important distinction. You've got average rate on one side. That's like figuring out your average speed on a long car trip. But on the other side, you have the instantaneous rate. That's what you see on your car's speedometer at one specific moment. And in kinetics, we usually care a lot more about that instantaneous speed. Okay, here's a little detail you absolutely cannot forget. Reactants get used up, right? So their concentration goes down. To make sure our final rate is always a positive number, because, well, you can't have negative speed, we just pop a negative sign into the formula for reactants. It's a neat little trick to keep everything logical. So, how do we actually put a number on this rate? Well, that brings us to what I'd call the master formula for this entire chapter, the rate law. This right here is the heart of it all. The rate of the reaction depends on the concentration of your reactants, A and B. But look closer at those powers, X and Y. These are the orders of the reaction, and they're basically the control knobs. They tell you just how much each reactant's concentration affects the overall speed. And here it is, a classic JEE trap. You cannot, and I repeat, not find the order just by looking at the balanced equation. It has to be figured out from experiments. That's totally different from molecularity, which you can get from the equation, but only for simple single-step reactions. Please don't mix these two up. You absolutely have to memorize these units for JEE. Seriously. A lot of the time, the question will give you the units for K, and that's your biggest clue to what the order of the reaction is. It's like a free hint. Okay, let's really focus in now. We're going to look at the two reaction types that make up something like 90% of the questions you're going to face on the exam. A zero-order reaction is kind of like an assembly line that moves at one fixed speed. It doesn't care if you have a mountain of parts or just a handful, the line just keeps chugging along at the same pace. The reaction speed is constant, and it completely ignores how much reactant you have. Now, for a first-order reaction, the rate is directly tied to the concentration of one reactant. It's simple. As the concentration gets cut in half, the rate of the reaction also gets cut in half. Now listen up, because this is a massive deal. The fact that a first-order reaction's half-life does not depend on how much stuff you started with, that concept is tested all the time. Whether you start with a ton or a tiny speck, it takes the exact same amount of time for half of it to react. Okay, so we've nailed concentration, but what's the other huge factor that messes with reaction speed? Temperature, of course. And to understand that, we need to bring in the big gun, the Arrhenius equation. This beautiful equation is what connects our rate constant, K, to temperature. It also introduces this really important idea of an energy barrier. It's the formula that explains why heating things up makes reactions go faster. So the key thing to get here is pretty simple. Higher temperature means more molecules have the energy to climb over that activation energy hell, which means a bigger rate constant. And that Arrhenius plot, that's a classic graph-based question. You gotta remember that the slope is just negative EA over R. All right, let's wrap this up with some pro tips. These are the shortcuts, the patterns that are gonna give you a real edge and save you precious seconds on exam day. This is such a powerful shortcut. Just think it through. To get to 50% completion, that's one half-life. To get to 75%, well, you have to react half of the remaining 50%, which takes another half-life. So total time, 2 half-lives. If you spot this in a problem, you know it's first order instantly. And here's another freebie. If you see anything about radioactive decay, uranium, carbon-14, whatever, it is always a first-order reaction. Don't even think about it. Just start using the first-order formulas and get that question right. And that's a wrap. That was your super fast revision of all the key ideas in chemical kinetics. If you master these concepts and remember these tricks, you're going to be in great shape to crush those questions on your exam. Good luck, and I'll catch you in the next one.